I have a triangle. It's a nice 45-degree angle here. It's got a T over here. It's got a 20 over here. And the question is, how long is T? Now, let me give you a hint. Cosecant, secant, and cotangent are not functions we're going to use for this. We don't need them. Never have to use them, so we would never do it. Okay? So we use sine, cosine, and tangent. So I start to approach this thing and go, all right, sine, cosine, and tangent. We're going to do exactly the same thing we did before, and that is to identify my sides. I really got to get a seating chart. This is going to drive me crazy. I'm going to say, hey, you. Borwick! I know your name. Ha! Top of the alphabet. You got it. Ms. Borwick! Tell me what the opposite side is. How's it labeled in my diagram? Opposite of 45 degrees. What's the opposite side? Yeah, T. So this is the opposite side. Where's my hypotenuse? Borwick. 20. Where's my adjacent? Borwick. The other one. I like it. That's well done. Well said. Okay, so I want to find what the opposite side is, right? Which side do I know, Ms. Borwick? The hypotenuse. So I know the opposite, or I want to know the opposite, and I do know the hypotenuse. Which function am I going to use? No, I don't have two sides of the triangle. I can't use Pythagoras anymore. Done. So which trigonometric function refers to the opposite and the hypotenuse? So it would be sine, right? So I'm going to go sine. And what's the value of the angle? 45 degrees. It's equal to, what's the opposite? T. Over the hypotenuse, 20. Now at this point in my illustrious mathematical career, I would have to then go get out the stupid trig book, flip it to the back of the book, find those stinking tables. But you have them in your calculator. So you're going to go ahead and just let your calculator do that. What is the ratio of the sides from the opposite to the hypotenuse? Now before you do that, what you're going to do is you're going to go into your calculator. You're going to hit mode, probably for most of you on the TIs. It's set up on the Casio. You can go a squared plus a squared equals 20, and then solve for a. Again, we're going to do 37 degrees. So that's, yes, you absolutely need to change degrees. So go to mode. If it says radians, if you just got your calculator of a box, it would say radians. Scroll down there and fix it to make it say degrees. If you've had your calculator for a while, you probably fixed this. So on the Casio, it's second function setup, and you're in degrees already, so you're good. So we go back to menu and out. Whoops. Menu. No, that's right. What the heck? Okay, hit execute. Clear. Oh, exit. We're desperate. What is going on here? Okay, whatever. Keep hitting exit as it gets there. Okay, now hit enter twice because it's a TI and they're stupid, and then hit quit. Maybe not. Quit. Can't get to the button. Quit. There you go. Holy crud.
I know.
Did I give this one to you?
Yeah.
Okay. You may need to get another one from me in a little bit. Okay, so it should be in degrees now. In degrees, count it. Should be degrees. Hold on. No, good. No, you're going right to the finish line. Good job, idea. A little early jumping to the finish line, but we will get there soon eventually anyways. Some of you already jumped the finish line. That's an interesting thing. That means that some of you learned something a while back, which is good. Most of you probably didn't. Okay, sine, 45 degrees. You put that in my calculator. You should get the following number, 0.7071. Actually, I need to go one more number. What's the next number? 0.7071. Oh, that's why I don't remember what it is. Okay, good.
Now what? This is the part that's most confusing for some of you, which is silly. What do you do next? How to get rid of the 20? It's algebra 1. How do you get rid of the 20? Multiply both sides by 20. Now, those of you who already wrote 20 sine of 45 good degrees, as long as you know what you're doing, I don't care that you do it my way. That's fine. We're eventually going to go that way, but it's going to be well if we get there. What do I get? 14.1. What does it say to round to? The nearest 10th. Now, why are these instructions always going to say round? .7071, is that an exact value?
Yes.
No. Go ahead and look at hit sine of 45 degrees. .7071, 06, 7812. Why did it stop at the 2? Because the rounding device, it's going to keep going. It goes on forever. It's actually the square root of something or the square root of something that we'll discuss later. So because that's true, we're always going to have to round it if we're going to use it. Unless we happen to know exactly what it happens to be. In this case, we might, but in most cases, we won't. Okay, so it's always going to be a rounding question. So read the instructions. Go back and go, what am I allowed to round to? Oh, I'm allowed to round to this. That's my answer. Fair enough? Keep as many digits as you can up to that point. All right, try the first problem in the back. It's got something nasty right there for you. Go back to worksheets just to get it straightened out. I hear the O's, which means people have found it. Number 2.
I don't see. Hold on. Maybe you're right, actually. It looks like there's wait, am I elevations to the top of the cliff and then top of the tower. So yeah, it's 50
My last calculator. Where are you peeps? What?
How do you determine what's the numerator and what the denominator is? I did 9 over
Opposite over adjacent. So 49 degrees. What's 49 degrees here? Did I do it right?
Yeah.
Yeah. So 49 degrees is here. So what's the opposite of the 49 degrees? That would be opposite. Right? This would be the hypotenuse. So that makes this the adjacent degree. Okay. Tangent is opposite over adjacent. That's all you do. And do that consistently and you'll never have a problem. So when people try to take shortcuts on this, that's when things go really badly in this. I don't have a calculator. I have no calculator. I'm out of calculators. It's sad and hilarious. Oh man. Teacher, I'm prepared for class.
Yeah, so 160.
Recording nothing. Pause that for a moment. 10.4 equals B.
Yeah. You have like double mine. Yeah. So yeah, we have I was gonna go up. Yeah, me too. No. Here we can. So we're using cosine. Yeah, I know, but it's going to be less.
Got it? Got my calculator. Thank you.
Yeah, so wait, 2 in theory, I mean technically it's 1, but so it's not 2. It's not 2. Remember when I was doing because it's not, it's exactly Oh, so we're moving the ones that aren't. Yeah, so if so 4, 8, so it can't be 12. Yeah. Wait, 12 plus 8.
Please don't get 12.
4 plus 8. No, it's not. I meant like 4 plus 8. Sorry, it doesn't be 12. Wait, I did this for I know exactly what you meant. Like, that's what I was doing. Yeah. So, 8 plus 6 is 16. Okay, so technically,
Yes.
it could be 6. It could be one or the other, but let's say that it's neither. Well, because we don't know.
You got 14, right?
Technically, like, split them, but it can't. But it can't be exactly 8 weeks. And no, it's not. No, I know. Right, but if the history book wasn't 8, if the history book was like 4, then it could be 16. Because it's not exactly.
So you check your answer.
Oh, so it could be, but I'm thinking that that's what they want to get. So we could do like a light X over 12 and 16, because it's probably
So we
not.
have the adjacent and not the high.
So if we can find out what the history part is, that's fine.
4, 9. Rounded there is 10th.
So it's 0.9.
Because that would be
9, because that was 0.
Oh, 9.0.
0.00.
Or was it 0.900? Where was it?
this one.
It can't be 0.9.
It's not the answer from Meyer though.
That's not even 9 either. Something's wrong.
Oh, wait. Wait. You already did Meyer.
So that's
Right, because if they're different.
Will? Really? We do?
Okay, so that's 56.8, right?
Nobody. Oh, so that means that you must.
Okay.
They're doing it too.